there were some questions about the mechanics of solving some kinematic problems. People were having no trouble determining V0, VF, and delta S, for example, but were having some trouble with the algebra of dealing with these equations. A specific problem involved a car that stops from 90 kilometers per hour in a distance of 50 meters, assuming a uniform acceleration. Then we want to find things like the time interval and the acceleration of the automobile. Before we proceed, we should change the 90 kilometers per hour into meters per second. 90 kilometers is 90,000 meters. An hour is 3,600 seconds, so that 90 kilometers per hour is 90,000 meters divided by 3,600 seconds, and that comes out to be right at 25 meters per second. Now in that case, the individual who asked the question knew very well that this was the equation that would give him the acceleration, and also knew that these three quantities were known, was just having a little bit of trouble with the algebra. So let's look at how we would go through the algebra here. We begin by solving this equation for A. Now since V0 squared is added on this side, to isolate A we're going to want to add a negative V0 squared. So we add a negative V0 squared to both sides. We do this before we multiply by the reciprocal of 2 delta S to get rid of the 2 delta S and isolate A. If we'd multiplied by the reciprocal here, we would have had to multiply by the reciprocal here as well as here, and that would have made the whole thing a lot more complicated. In general, if we can do something by adding the same quantity to both sides, that's what we're going to do before we get around to doing multiplications by reciprocals and so forth. In any case, having added the negative V0 squared to both sides, the equation clearly becomes VF squared minus V0 squared equals 2A delta S. And to isolate A, we're going to multiply by the reciprocal of 2 delta S. And we've done that over here. I didn't leave myself enough room to write this on this side of the equation, but I wrote a 1 over 2 delta S multiplied by the left side, and then I have the right side multiplied by 1 over 2 delta S. It's too small to read. But if you get up close enough, you can almost see it. And having done that, the 2 delta S in the denominator here will divide into the 2 delta S in the numerator, give us 1, and 1 times A is just A. And over here, of course, we're going to have VF squared minus V0 squared over 2 delta S. If we then put our information into the equation that we've obtained, we easily get our acceleration. I made a little mistake here. I should have written 0 squared minus 25 meters per second squared, and I put my 25 meters per second squared in first. I had a minus sign here because I wasn't thinking. I just wrote that where the initial velocity should have been, so I had to go back and fix it. The initial velocity, of course, is the 25 meters per second squared, and that should be subtracted, so I've got the negative there. And then the square of the final velocity is there in a positive sense. So we just put this in, and we get an acceleration of negative 6.25 meters per second squared.